Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. Always remember to subscribe so that you are notified every time I upload a new video. Today I want us we look at Pure Mathematics 2 and page 9, and I want us to explain, or rather to understand, example 8, which says under the factor theorem subtopic, fx is px cubed plus x squared minus 19x plus p. Given that 2x minus 3 is a factor of fx, find the value of p. Fine. You remember in some previous videos we said that if ax minus b is a factor of a function of x, then fb over a is 0. And this one is just in this format. There is a general comparison, ax minus b. And in our question, we have 2x minus 3. So fb over a, as far as that one is concerned, is going to be compared with the function of 3 over 2, which must be equals to 0 if 2x minus 3 is a factor. Having said that, we need now to substitute this in the function. We need to substitute that in the function and have p 3 over 2 cubed plus 3 over 2 squared minus 19 3 over 2 plus p. And it goes without saying that p multiplied by 27 over 8 plus 9 over 4 minus 57 over 2, of course, minus 57 over 2 plus p. This is what must give us 0. At that particular point, we realize that 27 over 8 plus p, 27 over 8 plus p, that is p 27 over 8 plus 1, because we have just factored p outside, is equals to 57 over 2 minus 9 over 4 is equals to 57 over 2 minus 9 over 4. Fine. Generally, if you clean up a little bit this part of the equation, you're going to find that 35 over 8p is going to be equals to 105 over 4. And it goes without saying our p, if you just multiply both sides by 8 over 35, our p happens to be 6. Let me just talk about 105 divided by 4 times 8 divided by 35. And what do we have? A 6. We have a 6. Correct. Having realized the value of p, that is the first part of the equation. But of most importance, please remember that if ax minus b is a factor of fx, then b over a is always equals to 0. Yes, part b of the equation, it's telling us to factorize completely. When we talk about factorizing completely, it means we come up, or we try to come up with some linear functions And this is what we mean by factorizing completely. Because p is 6, we have 6 x cubed plus x squared minus 19x plus 6. Now divided by the divisor, which is 2x minus 3, 2x minus 3. And using the long division, we can have 6x cubed divided by 2x. This is 3x squared. Multiply out 6x cubed minus 9x squared. And this is going to be 10x squared. When you subtract the 2, you drop minus 19x. Again, divide 10 divided by 5 by 2 is 5 plus 5x. Multiply again 10x squared minus 15x. This is going to be minus 4x plus 6. Let's drop it. We've dropped the 6. Minus 4x divided by 2x is minus 2. And of course, multiply out minus 4x plus 6. And the remainder is 0. The remainder being 0 again confirms that this 2x minus 3 is truly a factor of the function. We already have one linear. This divisor is a linear. But we now have a quadratic expression which needs to be factorized further, and we're talking about 3x squared plus 5x minus 2. If we take this to be 0, although we don't necessarily need to take it equals to 0, we can just factorize out the way it is. Two numbers we add, they give us a 5, and the same numbers we multiply, they give us a negative 6. This is basically positive 6 and a negative 1. So 3x squared plus 6x minus x minus 2. So you have 3x, x plus 2 minus 1 is common there, x plus 2. So we have two brackets, x plus 2, and then 3x minus 1. Because we are told to factorize fully, then fx becomes the divisor, which is 2x minus 3 multiplied by x plus 2 multiplied by 3x minus 1. And yes, we have managed to give 3 linear expressions, and this is what was expected of us. This is what was expected of us. We have been able to factorize fully, and of course you can see this is our final submission. Yes, when we divided the function having acquired p, we divided by 2x minus 3, we got this as a quotient, but it was still a quadratic expression which needed to be factorized further, and we have used the BAC approach, product and sum approach, and we have gotten our factors to be 6 and negative 1, because you multiply 6 and negative 1, you get a minus 6, and you add 6 plus minus 1, you get a 5. This is what has given us all this, and that is the final submission. All right.